So we've structured today's meeting into three sections. Suresh, if you could advance to the agenda. So first, Suresh will provide some updates supported by recent additions to our investor deck and a preview of what POET and SPX will be exhibiting at the CIOE in Shenzhen, China, the largest of all the optoelectronics shows. We had expected to preview the live demos we planned for CIOE in a press release, but the show has been postponed due to the 2-week lockdown of Shenzhen. We don't have a firm date for the replacement show or the delayed show. Second part is that Kevin will review some of the mechanics of warrant conversions. Our new transfer agent, Computershare, is very fussy about all the forms being filled out correctly, and the process takes longer than you might expect. Even though the warrants will only begin to expire in April of next year, we're here today to ask each of you, many of whom are our largest shareholders, to exercise the warrants early and to hold and not sell the underlying shares. This is something that Suresh and I have done recently and other insiders are in the process of doing. We are asking you to follow our lead in order to help us lengthen our cash runway, since the cash from the warrant conversions comes directly to the company. We need to extend our runway for 2 reasons. First, to give us time to complete some agreements and projects with companies that we hope to be able to announce into the fall and later in the year that we believe will represent important developments for the company. And second, to give our shares and the overall market time to recover from the downdraft we have suffered these past several months. So the third section is a Q&A period. In the meantime, I'll turn it over to Suresh to begin the presentation.
Hi, everybody on the call. Thanks for taking the time. Again, I know it's 6 o'clock in the evening for most of you on the East Coast. What I intend to do today is to give you kind of a status update on where we are with our product development, but really, underline my firm belief that, we are developing something very special. It takes time and, we need patience, but you guys have all stood by me so far as I've tried to transform this company into delivering something meaningful and of high value and high potential. And, more so now than ever, I'm convinced we're on the right path. Even since the Brussels conference, we get so many inbounds on, a variety of projects, and we just can't take all of them unless they are directly applicable to what we're doing. So we're parking them till we deliver on, what I think are meaningful achievements over the course of the next couple of quarters. And then we'll, but what it proves to me is that what we're developing is of universal interest and value. And that's what I would spend a bit of time talking to you about. So, you've heard me say this, the key challenge in photonics, the key challenges are volume. Can you deliver in the high volumes required, not only for today's applications, but for applications in the future? Form factor or size is becoming critically important because these modules are fixed in size. And as you keep increasing frequency, you have to fit more and more stuff inside of that fixed size. And without integration, that becomes impossible to do. And we POET have a distinct advantage in terms of integration and size. Since everything we do as wafer scale manufacturing, and you heard me say this as well, we do, when we ramp production, have a disruptive cost advantage, so in the assembly piece, as well as power consumption. Some of the things that we're doing on the interposer dramatically reduce power consumption because of the size. I mean, when the size is small, the distances that electrons need to travel is small, and that consumes lower power. So these are the key challenges in photonics, and current technologies, do not address universally all of these challenges, and we do. And more so now, over the past couple of years, we've added so much capability into our interposer that, of course, we've faced challenges along the way, but, we've also overcome all of them. And I'm very confident that we're on a path here to being able to, provide, basically meet my vision and mission for the company, which is dear and dear to me, right? In terms of what we want to do. So if you look at the data communications roadmap, it keeps moving forward, right? When I first joined POET, it was 2015. Early in 2016, 40 gigabits was the highest volume product. 100 gig had just started ramping. This was 2016, so about 6 years ago. Today, 100 gig is the highest volume product. 400 gig has already kind of, moved into production. But when you keep ratcheting up the speed, current conventional technologies have a hard time beyond 400. Even at 400, they're, not as probably as efficient as what we could do with our interposer. But as with any technology, I mean, there are incumbent solutions, and there are incumbent solutions at 400 as well. But when you get to 800, then you look forward to 1.6 terabits and beyond, the roadmap ends, and an integration is needed. I think, for those of you who follow what happens in the world of CMOS, there was this planar technology. Planar CMOS kept, going on, quarter micron, 0.18, 0.13, and so on and so forth. Then you reached a point where planar CMOS, the roadmap was dead. I mean, if you didn't do something different, you didn't proceed. And then 3D technologies like FinFETs and other things came online, and then the roadmap continues. In the optics space, we're kind of in that point where conventional technologies have taken it up to 400. In fact, even at 800, you can see conventional technologies that are out there today, but they're done in such a complex manner that it is hard for them to scale it up. So at 800 gig, there is a discontinuity where conventional roadmap ends and some form of integration is required. And POET is really well poised to provide that integration. Now, of course, in hindsight, you could say, well, why did we not shoot for 800 right off the get-go? But it's tough. I mean, we're developing something completely new. We had to validate it with current solutions, which we did successfully at 100, 200. And now, with all that experience behind us, I feel supremely confident that we're going to be successful here at 800. We, POET, can support these pluggable form factors all the way up to 3.2 terabits per second when conventional solutions struggle to deliver 800. Now, we're not the only ones who say this. So this is a slide from a presentation from one of the top 10 module companies in the world, 8G Genuine. And they say, we have reached the limits of discrete subassembly. We need photonic integrated circuits. Basically, the channel counts have increased so dramatically, 8 channels, then 16 channels. The complexity of these subassemblies have increased dramatically. And what people want is an integrated solution that just replaces all this nonsense, right, with a chip scale form factor. And that is exactly what we're doing, right? And so we're having some very interesting dialogues now, because for the first time, perhaps the industry has acknowledged that, okay, we got to make a transition, and we're able to have these conversations on the backs of, the progress that we've made over the past couple of years, and improving and demonstrating that our solutions are in fact scalable, and they do work, and they do meet the requirements of the market. And all of that was important stepping stones for us to get to this point. Now, data communications has progressed systematically through increasing channel counts. And that's where multiplexing and these other forms of components that we incorporate in the engine comes in handy. At the 10 gigabit per second range, there was only one lane. 40, it went from 1 to 4. And then at 100, it stayed at 4, 200, it's at 4, 400 is at 4, fine. Current technologies, even though they may be kludgy, they work. Get to 800, suddenly it's 8 lanes. Get to 1.6 terabits, it's 8 to 16 lanes. 3.2 terabits, 16 lanes. So it's very clear that once you get to about the 8 channels required, especially in a multiplex solution, it is not possible to make these devices. This particular company, they do it today. I mean, they do have samples out, but they're also very open in saying, we can do it. We can do it, we can put samples out, but try scaling it up in terms of cost, scaling it up in terms of volume. This kind of, complex assemblies don't work. In fact, these assemblies from many customers or potential customers use up to 50 individual pieces that they put together. And you can imagine that you could, these are engineering feats of marvel that they're actually able to do it, but can you actually scale it? Can you get to the cost structure that you need? Those are the issues. And we have just completed, happy to say, a design for the 800 gig that looks like what I show on the picture below. It's 75% smaller. You fit the receiver and transmitter side by side right next to the DSP, and most of the module is actually empty. You can see readily how a solution like this, not just addresses kind of the cost, scale, volume piece, right? But the proximity to the DSP means better power. All this empty space in the module means better thermals, better manufacturability, right? And so we are extremely bullish about our ability to really make a splash here. I mean, people have been paying notice to POET. I mean, in most of the presentations I see now, we are a prominent potential supplier of integrated, photonic integrated circuits. So we've now built a name. People are watching us, and I think this 800 gig is really going to be the linchpin, right, in terms of being able to really swing that pendulum. And I'm more confident today than I've ever been that this is the path. And everything that we've worked for so far has brought us kind of to this culmination, right? So we look at key competitive differentiators, and we compare what we do at POET to what other vendors do. And these are actually vendors of silicon photonic solutions. They include the Intels of the world and the Marvells and so on and so forth. And we competitively compare what it is that we could do with what others offer in their quote unquote silicon photonic solutions. And you can see that, when it comes to a full featured set of solutions that are truly integrated chip scale, we're the only ones who do it. And that's because we've chosen this interposer path, right, which is a hybrid integration path that allows us to truly put all the pieces that are necessary in a chip scale form factor, as opposed to just the transmitter or just the receiver or just the modulator, as some folks do. So there's a lot of hype in silicon photonics, and for sure, and I'm not trying to compete with them. They're a component supplier, we're an integrator. But what I would say is that most of those solutions are incomplete, and they don't quite get to where you need to be. And we've consciously engineered what we need to do to being able to provide a complete solution That applies not just to data communications, but other market verticals as well. We've got inbounds on sensing, we've got inbounds on some space applications that I'm having conversations about. People generally like this concept, right? It's just going to, we need to complete the 800 gig. It is critically important for us to do that. And I'm supremely confident we can before we, take some of these other applications on as well. So we have a very strong value proposition at 400 gig and beyond, but my sights are right now within the company set on 800. The strategy is deliver 800, which is a 2x400 solution, show that we could actually fit it in this form factor that is insanely competitive, and then go two ways. We go backwards by value engineering 400, because 400 has been in production for a couple of years. So people over the life cycle would like to value engineer and get to a lower cost solution. And then propel forward to 1.6T and 3.2T. It's important we plant a flag, right? We want to plant a flag at 1.6T and say, hey, we could do it. In fact, at the CIOE, we were going to demonstrate, and we will when the CIOE comes, a full 1.6 terabit receiver. I want to leapfrog, right? And I want to leapfrog from, a robust base at 800. 800G is an inflection point for rapid growth in the data centers. It also extends this preferred path of pluggable optics. There's a lot of debate in the industry on co-packaged optics versus pluggable. To the extent that you can keep doing pluggables, it is the preferred form factor. And we believe we can provide a roadmap extension definitely to 1.6T and potentially even 3.2T. And our technology surpasses all others at this node in terms of size, power, cost, ability to scale, design flexibility. If you take up so little room on the module design becomes very easy, which is why we're also contemplating perhaps just doing the modules. All of that requires time and investment, and we're being very cautious with how we spend our money. But surely we need to put more wood behind these arrows. I've been very vocal this past 6 to 9 months, more so than I have before, because that's me. And I was conservative to begin with. I wanted to make sure that what I said, had credibility and weight. And now I'm being very vocal. I'm gonna be at Basel at the ECOC conference in a couple of weeks. I've been invited to give a talk in March at the EPIC conference. So I think people like what we're doing and want to hear more about it. So 3 things with the interposer we want to do. One is not just enable a solution, enable the solution for 800 gig to 3.2 terabit. And we're going to do that using our optical interposer platform with the directly modulated lasers. We're very close to securing a supply for these lasers, and we will likely be in a position to announce something there. The second thing is the light sources. The light sources for high bandwidth communications, light sources for high performance computing. This is the future of computing, the next generation computing, AI, ML, artificial intelligence accelerators. We can reduce the cost of these light sources by 75%. We've got a win with Celestial, as you already know, and we're chasing other companies like IR Labs, Luminous, et cetera. Many conversations with some of these folks to, get to being a solution supplier to them for remote light sources. So the interposer platform, again, for these sources that require 4 to 8 to 12 to 16 lasers in a tiny form factor that's going to fit next to your graphics card on a PCI Express board, you can't use clunky, assembly techniques, right? And so there's a definite, market for us here. And, this is, you could say, AI, ML, I mean, people, it's futuristic, but really the business is there in 2024 and beyond, and it's big business. This is now a one-to-one attach rate of photonics to a silicon chip, right? Imagine if every microprocessor you had in the world needed a photonics chip for it to function. That's what these remote lasers are. It's like DRAM is to a microprocessor, a remote laser is to a AI/ML accelerator in the photonic space. So these are large volume businesses, and we believe we have the right solution. So these are our two primary focus areas today. And this is what is consuming my team, my time. And we're working very hard to get get this over the finish line and into production next year. The third tenet with the interposer is integrating new materials. We know that there are new materials on the horizon that are even better than silicon photonics, like lithium niobate. We've had an engagement with a company there called Liobate. In fact, at the CIOE, we're going to be demonstrating a 400 gigabit lithium niobate transmit solution. So the interposer is a critical component in allowing these new material systems to kind of shine, right? Whereas they don't in on by themselves, they have no integration potential at all, right? And the interposer with its hybrid integration allows for that roadmap extension with new materials as well. So those are the three things that we're working on in the company, right? Make the solution for 800 gig, which then allows a value engineered 400 and flagship 1.6 terabits. Light sources for AI/ML, big market, huge potential, ramps a little later, 2024, 2025. But at 2024, 2025, it's millions of units a year at a couple of $100 ASP, right? So you can do the math. That's big business, and we have to succeed there. And I know, we say, oh, wow, we're in 2022 now. That's 2024, that's 2 years, but 2 years flies in no time, especially when we're talking about needing to prepare ourselves to deliver that kind of volume. And then, new material plays. So we are aiming at these two critical market inflection points. They really take off in 2024. We want to get samples out on these by first quarter of 2023. I want to be at 400, 800 so that we can ride that wave. I'm trying to, shoot ahead with 1.6T today so that we can, be a flagship provider as opposed to, being late and slow. And I think one of the things we've done at the base interposer platform development is it's allowed us to, if the components are ready, we're able to put a solution out. And so now with this secured supply of DML lasers that can take us all the way to 800 gig, we're very, very confident that we can get there. So our go-to-market plan, so this is a chart. I mean, any of you who have done any kind of volume business, you know this, right? Where you started the market, you're at market pricing. Then as you go into production, the price drops, the cost drops, and you start making money. So in the early stages, it's market pricing. Whatever you charge, they pay. The volumes are really low. After that, your cost is dominated by your bill of materials. And then finally, your cost is dominated by manufacturing. In fact, in this blue period is where people make most of their money, which is, cost of manufacturing. So on this curve, 100, 200 is on the extreme right side. I told you it's about 4 or 5 years in production. So it's already at a fairly low cost point. So we're using this to prove out our platform, to prove out the technology, get customers engaged. Even if they're not interested in 200 gig, they see it, they kick the tires. We're getting market acceptance, and it's a tech prove-out vehicle for us. We do have customers on 100 gig LR4. LR4 has another 10 years of life, so we are, excited about that. But for FR4, or CWDM, we have customers. It's going to be a small volume, but it's a really, really critical technology prove-out vehicle for us. From there, we're going to leapfrog to 800. And that's because 800 is now in this yellow phase where it's just about getting started. No really good solution for 800 FR4 in the market yet. And our reduction in bill of materials, as well as this disruptive manufacturing advantage you get in the manufacturing period, makes that a really good solution. 400 is in the blue right now, but there are enough customers who would value engineer because there are many, many years of production in which they can recoup their cost of retooling and make their margins due to the disruptive manufacturing costs we offer. And then finally, 1.6T is a game changer. It's the flagship. And I just finished a design today on the 1.6 terabit product receiver. It's going to tape out to Silterra this weekend. We are already demonstrating the 1.6 at CIOE, but this will be a production part that will go to customers, and we will be demonstrating it at the OFC conference as well. So I'm trying to leapfrog here from here 800 to 1.6T to plant that flag that says, hey guys, everybody else is struggling at 800. We can readily scale to 1.6T, right? That's a statement. And I'm confident we can do that. So our manufacturing value add through the interposer, we said this before, wafer scale assembly and test, no active alignment, fiber attach capability, low loss. Eliminate all the wire bonds. We have through silicon vias in our interposer that can go to the PCB directly. And it's a complete solution with integrated electronics. We're working with MACOM on the drivers. We're working with MACOM on the TIAs and a couple of other providers. And we are basically incorporating their electronic components onto our interposer. So it's a complete solution. When we talk 800 and 1.6 terabit, it's a complete solution. So our go-to-market plan, we're now sampling and selling to module customers through Super Photonics. That's the extreme left. This is 100, 200 solutions, also 400 gig receivers. We're actively in development on the 400, 800, and we expect those to sample in 2023. And as you can see, the ramp starts second half of 2023 into 2024. And then there we have basically the roadmap extension from 1.6 terabits all the way to 6.4 terabits. And at 6.4 terabits, we did a design with a 3-dimensional stacked transceiver. Nobody's ever seen that before, where we've actually stacked the receivers on top of the transmitters to pack that density. I mean, the capabilities are endless. We're limited by our own bandwidth. We're limited by our own ability to invest. I mean, I'm doing a 1.6 terabit transmit and receive at $1 million of R&D spend a month. And I'm competing with InnoLights and Finisars and, billion-dollar companies, right? So that goes to show that what we have is simple. It can be done. And we're poised to do it. Now, as Tom said, of course we could do with investment, and you guys have supported us over the years. I know you've trusted me personally, and I can tell you that I'm extremely confident of the path that we're on, and I would urge you to help us put some more wood behind these arrows, so we can take it, to the finish line.